Welcome. Thanks for joining our Drive Electric Week virtual sessions, DIY perspectives on EV conversions. I'm Aaron Choate, the president of Austin EV, the local chapter of the Electric Vehicle Association. And Kevin Carafa will be giving our presentation today, and then I will be opening the floor to questions. Feel free to put your questions in the chat and I will share them or invite you to unmute so you can ask them yourselves. Okay, Kevin, please go ahead.
Well, hello everyone. Thanks so much for joining the session today. We're going to talk a little bit about do-it-yourself electric vehicle conversion. And I actually am owner in a shop here called Austin EV Only. It's the banner here on my shirt. And our business is primarily repairing Teslas. Some of the basic things that the service center can't get to. But along the way, we realized that a lot of folks have reached out to us and asked us if we could help them convert their electric vehicles. And it's actually become, by and large, the largest piece of our portfolio is doing electric vehicle conversions. So I'm going to share a story with you here about one of the ones we've done. And we are so new to the process that I think even from a DIY perspective, there's a lot to be gained. You know, we are, you know, quote unquote professionals, but every time is different. Every time is new. And the lessons are so fresh in our minds that I wanted to share them with you because I think they're relevant for anyone who's looking to undertake that process. Because of this format where we're virtual today, I would love it if you guys could come in the shop and tour the vehicle that we're working on today. But I understand that due to limitations, it's not possible. So what I did instead was I set up a slideshow, and please forgive me. You know, I was thinking that rather than take my computer with its not so great internal camera and walking around the shop, that I would instead just show you all some candid shots where I could get in really close, you know, with a decent sized camera and go through that with you. So, you know, I hate to make this like, you know, I remember my grandma used to do slideshow and of her vacation trip photos and would bore me to death. So I hope that's not this. Please feel free to put your questions in the chat. I told Aaron explicitly to interrupt, you know, so that we could answer those questions live. So, you know, again, don't feel shy about typing your questions there. So again, here's my contact info, Kevin Carafa. Our company is called Austin EV Only. And you can reach me at owner@austinevonly.com. And real quick, I'll jump here to the website, just show you kind of quick look around and then tell you a little bit more about what we do here. So hopefully everyone can see this. I just went real quick and just noted, you know, in the R services, Tesla repairs, you know, what we started out doing. And it seems like full EV conversion is what we spend the most time doing. And if anyone is interested, I'll just shamelessly plug this here. These are some of the Tesla services that we typically see and we typically hear about. So with that, back to the presentation here. So we're relatively new, founded in November 2020. It's a small team of three. Myself, Kevin Carafa, I have a background as an electrical engineer. My fabrication specialist or machinist, Carlos Hernandez, and then a marketing and strategy specialist, Gurkaran. And together, again, we're trying to attack the EV market. I feel like, especially here in Austin, there's a big need for a lot of these services and limited options out there. And the shameless plug, we are actually looking to expand our team. So if you know of anyone or you yourself have an interest, we're looking for welders or CAD specialists to help us along our journey. So just keep that in mind. So let's talk about the project and what we're working on here. I don't know how many folks have heard of this company here in town, Literati. They are a book subscription service, and they focus mostly on children's books. They reached out to me through the website and asked if I could convert their bookmobile. They call it Bookmoto. And it seems like such a great project and such a great partnership that I absolutely, you know, agreed and jumped in full-fledged to take this on. So this, I want you to kind of memorialize this picture in your mind. This is what it looked like, you know, on day one when it showed up to me. And I'll take you through, you know, how much it's changed over the last couple of months here. So let me take a pause here. You know, you're here to learn about EV conversion. So let's talk about the steps necessary to do a conversion. It's not a small undertaking by any means. I don't know if I can't see if Fred's out there, but he definitely warned me before undertaking this. having been in the community for a while. And let's see, yeah, I see him on. So, and said, hey, this is not a small undertaking, so you really need to plan and double lead that. So I did quite a bit of research and planning. The first on the research piece, sorry, let me go through the steps. Research, then the planning piece, which is actually like, okay, let's figure out, what parts we want, where are the parts going to go, how's that all going to work. If there's anything that you can't figure out on your own, you're going to have to outsource that. So this is a make or buy decision. And so in a lot of cases, I realized that I alone don't have the technical specialty in all the areas necessary. There's electrical, there's mechanical, there's software programming, there's CAD, there's all these different pieces that need to come together. And I'm not saying that no one person can do it, but I'm just saying it goes a lot faster if you have experts in each area. And with Literati, they specifically asked if we could go quickly, as quickly as possible. They stressed that multiple times throughout the project. And so anywhere where we could reduce the total life cycle of the conversion, I looked for areas where I could buy expertise as opposed to acquiring it myself. And then ordered the parts. We're right now in the assembly phase. So unfortunately, I can't show you a finished product today. And we're only working on the one right now, but I did want to show you kind of where we're at and how that's going. And then of course, once we finish the assembly, we'll get into testing phase. And so we're not there yet. And I don't have much to say on that today, but it should be fun. So let's jump to the next slide here. So research. So, I read the following two books, and in retrospect, looking back, it probably didn't even begin to scratch the surface of things I needed to think about. These two books that I picked up, and I read cover to cover, and I was like, hey, I can do this. This shouldn't be too hard. It's focused on the electrical. And as I mentioned, I'm an electrical engineer. And so this seemed very familiar to me. And going through it, I didn't consider some of the other pieces, but, we're here now and we're almost done. So at the end of this, being an electrical engineer, I put together an electrical block diagram. This actually is not that complex. I'll just break it down real quick. Over here on the left is a battery pack. The battery pack needs a number of things. First and foremost, a battery charger and a DC-DC converter. And then if we just skip over here through a main contactor, which drops down to the controller, which then drops down to the motor. So at a very high level, I'm like, hey, there's only like 6 blocks or 7 blocks that you need to really focus on. And everything else is more like this is all here is safety. This big green box here is instrumentation. So just think of those as, black boxes, input in, input out, and don't worry about what's in the middle. So I'm like, okay, there's only really 6 things I need to worry about. Battery, motor controller, battery controller, DC-DC converter, and a couple other things, like potentiometer, some other stuff. So I'm like, great, I got this together. I'm ready. Let's do this. So the first thing I did was, hey, we've got to kind of break this thing down. So I had the shell of the bookmobile removed, the bookcase, if you will. I had that piece removed so that I could really get at the internals. And very quickly realized, hey, I definitely know my way around auto repair. I'm not new to that. I've been doing that for, 15, 20 years now. I've been doing auto repair. So I definitely know my way around. But at the same time, welding, fabrication, that is not my specialty. So the very next thing I did was seek out a specialist in fabrication. The first person I went to that Fred recommended was like, hey, do you have any CAD drawings or do you have specifics? And I said, no, I have no idea what I'm doing. And they were like, get lost. So that didn't work out. And then I went to another machinist. They had their own on-site CAD capabilities, and they saw the book moto and they saw how cool it looked. And they're like, we would love to take on this project. We will be happy to do that. So I partnered with them. Before bringing it to them, I removed the motor. Actually, it was very easy. It probably only took me 5 hours. I had it done like the first night I got it. I took the motor off, just with reckless abandon, undid every single bolt I could find until the thing just basically fell off. So then I was left with this, which is, a motorless differential and axle. And looking at this, I quickly realized, how am I going to attach an electric motor to this? What am I even looking at here? I'm out of my element. I need help. So that's when I came to the folks here at Astro Mechanics. Let me just make sure I did this last time. I want to share the audio before I hit play here. There it is. Okay. And then where did my presentation go?
We've moved into the,
There we go.
you are.
Okay, so I'm gonna hit play here.
So I know this
Can
is
everyone hear this?
anticlimactic, but I got busy dealing with the guys and I forgot to record the conversation we had, but basically just kind of talking about what we want to do. One of the things they suggested was to remove this deck here and make things easier for them, and I agreed 100% that that would be easy, easier for everybody. So I'm hoping that we can all work it out. But I'm looking forward to seeing how this turns out mechanically. Electrically, that's where I come in, and I'll take care of that. But the mechanical piece, that's what Astro Mechanics are all about.
Awesome. Sorry if the audio was echoing there. So in summary, found a machine shop that did the mechanical piece. And so now we're in the world of machining and mechanics, and this is just not my realm, but I wanted to share this with everyone so that they know, like, it's not just the electrification piece, right? There's a whole lot more that gets into EV conversion. And, a typical EV conversion will involve attaching an electric motor to the existing, probably transmission, if you will, especially, I think it's manual transmission is probably the most common one. And you get the bell housing of that transmission and you match it up with your motor and you put it together and boom, you're done. You need a special plate and a coupler and welding points and you're done. But this was much more than that because I couldn't figure out how to easily attach. So I ordered a whole new transaxle, and the customer, Literati, wanted this done immediately, as fast as possible. And while the perfect transaxle existed in China, everyone's aware of the global supply shortage, the supply chain issues. So it seems sensible to order a used transaxle. And I found this one on eBay and it looked great. And it's made for golf carts. I think this one came out of a Chrysler or Polaris Gem car. So I'm like, this is great. This is perfect. This is what I need. And so I ordered it. 3 weeks later, it showed up and we're like, okay, now what do we do? So we've got a lot of guys at the machine shop standing around, looking at this thing, scratching their heads and trying to figure out what to do. And I'll point out there's 3 gentlemen here, starting from the left. This is Carlos. He is my machinist, the in-house machinist. And then these other 2 gentlemen work for Astro Mechanics. Joseph, he's the actual welder. And then Butch, he just stands around and tells people what to do. So now they're trying to figure out what to do, and they've removed the deck, and we've put in a framework, if you will, to hold the old deck. And we're like, okay, wait, how do we attach, say, these shocks here and the strut towers? And they said, you know what, we've got to start over. So even though they're a professional fabrication shop, they didn't even consider how to attach everything. So they had to tear this whole thing apart and start over again. So here we go. So now they started over again, and we've got what will end up being the finished product here. And so what you're looking at is completely manufactured. I wanted it done out of aluminum, and they said, listen, kid, there's a supply chain shortage of aluminum. Best to just go with iron. I'm like, fine, we're in a time crunch. Go do it. Of course, if I had it to do it over again, maybe I'd say, hey, whatever the cost, because this thing is heavy now, so heavy with all the iron. But the little box here is where the battery will be stored and a number of electronics. And then this platform is twofold: 1 to hold the new transaxle, and 2 to support the bookcase that came off on that forklift that I showed you all earlier. So real quick, we got it in. There's the new and the old side by side. And this is great. You can see that the new transaxle is beefier and can hold the torque of the motor, which are they're very high torque motors. So we want to make sure that it's up to the challenge. And just the old transaxle was not that. It was probably 40 years old. This, I forgot to mention, this vehicle, this Book Moto, it's a Vespa that's imported from Italy called a Piaggio 850, not manufactured in the U.S. Really hard to come by replacement parts because it's not a U.S. standard. And so just transitioning over to this Polaris brand with all U.S. parts just made a lot of sense. So any questions in the chat, Aaron? I'm going to keep going if not.
Not yet.
All right. Cool. No problem. So I'll keep going. So guess what? When you buy something on eBay, it may not be in the best of shape. And so we quickly noticed some problems here. One, the manufacturer cut the brake lines. The fabricator, Astro Mechanics, cut the brake lines, and they didn't, they're like, hey, we fabricate things. We're not auto mechanics. We're fabricators. So you figure that out. So then I, like I mentioned in the beginning, I'm fairly handy when it comes to automobiles, and so I had to figure out how to get new brake lines in the new transaxle, how to repair a torn CV boot, fine. But it just added to the timeline, and the whole time, my customer Literati is like, hey, what's the holdup? What is taking so long? And so, when I was planning on this whole thing taking, say, maybe 2 months from beginning to end, and now we're at 4 months, 5 months, and we're still, definitely deep into it. So going back to that life cycle, I talked about, hey, after we've done our planning, after we've done our research, we need to start ordering parts. And so the way I went about it was I just went to some well-known websites of electric vehicle parts. The first one I started with was called EV West. I feel like they're probably the most well-known, and looked at all of the parts they offer, just clicked on every single category. And then from there, started looking at some competitors. And I think, if you go to Google, they typically show you ads from competitors. So I went to Thunderstruck Motors, a couple others, and I ended up buying a kit from Thunderstruck Motors, which included the motor controller, the contactor, the potentiometer, all in one kit. And then they sold pretty much all the accessories to go with it. So I used them as a reseller of the batteries. They resold the battery management and charge management systems called BMS and EVCC. And then that just left for me really to figure out the wiring and safety on my own. And then the other piece to figure out would be the motor adapter plate, which again mates the motor to the differential housing, as well as a motor coupler, which mates the spinning part of the motor to the spinning part of the differential. So those two pieces needed to be machined. Enter my machinist. So I got to it. I started ordering parts. Here we go. I ordered 16 batteries and a battery controller system and a charging system and a charging control system and a motor controller and a DC-DC converter and instrumentation and of course a plug to plug this whole thing in, and a potentiometer, safety and contactors, and a whole bunch more little parts that could never fit on this screen. I'm out of space, so let's stop there. But, just went through, ordered it all without, considering the finer details, and just said, look, once this stuff shows up, I will figure it out. I'll just put it all together. I think I'm a smart guy, electrical engineer. I'll figure it out. So maybe or maybe not the best plan, but there it is. So I wanted to stop here and just talk real quickly about the motor, because this is kind of where we're at. So more problems ensued. The motor shows up. Apparently this thing had been sold and returned before, and then sold to me as new. And it is a new motor, except for one small detail, which is someone on the right side cut the coupler, which again mates the spinning part of the motor to the spinning part of the differential. And so this coupler is no good. I can't figure out how to get it off. I have probably the smartest machinists in town, and fabricators look at it. They can't figure out how to get it off. And so we agree, hey, let's send this thing back to who I bought it from and have them send me a never before sold motor that's as it should be. And that's on the next slide. So this is what it should look like, not silver, but black on the coupler. And the motor kit that I bought from them includes all of these parts. And the best part is everything was pre-programmed. So again, if you're not a software engineer, that's okay. They have kits out there that are pre-programmed, where the motor controller is programmed for the motor, or the battery management system. You just tell them your configuration and they program that for you. Not being shy about that, I actually went ahead and dug into some of the programming, and I'll show that in 2 or 3 more slides here. But I wanted to pause real quick and show, hey, this is the adapter. So you can see like 2 slides back, there's the motor on the left side with no adapter plate. And then here is a picture, and I don't know if you guys can see me on the video, but here's, what the adapter plate looks like, which is almost done. It's actually needs to have a couple more holes drilled in it. But, just that adapter plate alone, I think cost me like $1,000, for the machinist to make, because it has to be machined to such a fine specification that's how it goes. So then getting into this will probably be my last slide here. Getting into the programming, on the left side is a picture of the battery pack that I assembled. All of those wires go to the battery management system. And then on the right, you can see through the software in the battery management system, you're able to connect and monitor the battery voltage. And this battery management system helps to regulate the charging and discharging of those batteries so that they're safe. These are lithium ion phosphate batteries. And with lithium ions versus other types of batteries, it's very critical that those batteries are kept in a healthy state at all times. And while, you know, your normal 12-volt battery, say in your car, can be charged and discharged within a certain region without a lot of regulation, these batteries are a lot more sensitive, and it's imperative that they stay balanced. And so that's what the battery management system does, is it maintains balance and the health of those. So I'm going to actually stop there because this is pretty much as far as we got. You know, I'm happy to kind of take folks on a tour of the shop with my not so great laptop camera, but you know, this is where we're at. So I thought I'd pause here and we would spend, you know, the next, I'm sure there's a lot of questions. So I thought we would open it up for some questions.
Sounds great. Have you ever, I'm kind of curious, what other ones have you considered?
Let me remember the other guy that reached out. So the only other one that reached out, someone has, I can't remember if it was a Prius or a Toyota RAV4 hybrid, but he found this conversion system that's sold like out of the box that will convert a hybrid into a fully electric. And, you know, I told him I'm busy with this project now, but when we finish, I'd love to take it on. So that's probably the next one coming up, is this conversion, this kit, which will convert the hybrid to fully electric.
Okay. Let's see, is Regen built into the controller?
Great question. So, so a lot of folks ask, like, should I do an AC or should I do a DC? One of the advantages of doing an AC motor is the ability to do regenerative braking, right? And just so we're clear, because I know when I first bought my Tesla, I didn't know how it worked. You know, I thought regenerative braking had something to do with the brake pads and recapturing heat energy. It's not. It's basically using the motor in reverse. So instead of providing energy to the motor to make it spin, the existing momentum of the car and causing that motor to spin can be recaptured through the motor. And then in the controller, the motor controller pack that I bought, that is a capability of that system to recapture that energy and send it back to the batteries. Great question.
Okay, Anna has a question. Let me ask her to unmute.
Okay, the last slide that you were showing, you were looks like you are connected to the BMS somehow, and you're issuing commands. What is that talking to? Is the BMS has some built-in OS that?
Sure. Let me try to do the best to describe it I can. So Dilithium Designs, I hope I'm saying that right, is the manufacturer of the BMS I have. And they have the ability through the USB cable, which connects to the BMS. And then the BMS has a couple of different ways it can connect to other components like the EMCC through an SPI, which is, if I remember correctly, a 2-wire connection. And then it can, I assume you're asking about the connection to the computer itself. So it has this one in particular has 2 microchips on board, one for each bank of batteries. And those microchips can take in the signal, which I communicate serially through the USB to the BMS. Did that answer your question, Anna? Oh, cool. She's on mute. Great. Thank you so much. Awesome. So yeah, I have a lot more I could say as well. If there's no other questions, we can kind of go through and talk a little bit about each of the components, if that's preferred, or if there's more questions I can't see.
Yeah, go ahead and show. I'm kind of curious about the contactor choices that you made. Would you mind sharing some of the safety concerns related to the fusing and the contactors?
Sure. So yeah, let's take a step back from that and just say, like, how do we size this thing, right? How do we even start figuring that out? And so those who drive an electric vehicle may be familiar with, you know, the watt hours per mile, or sometimes it's inverted. And it's, but either way, you know, I need to figure out, how far do I want this thing to go? How fast do I want it to go? And what does that mean in terms of voltage, in terms of amperage, in terms of cable sizing, you know, all of those considerations. How heavy is the vehicle? How big does the motor need to be to power a vehicle of that size? So let me kind of run through that process. So, took out a pen and paper and just kind of started to back of the napkin, do some calculations there. And I figure that when this bookmobile is completed with everything that I've added and all the books, that it's going to weigh, let's say, 1,000 pounds. So that's, on the lightest side of any car I know, or on the heaviest side of any golf cart I know. So I was trying to find something in that range that was like a good motor for a golf cart or a very small car. And then we're looking at the AC9. Is that by NetGen? I can't remember. And then also looking at the one that I did get through I'm going to say this wrong, Mont Energy. They have a bunch of ME series motors, and kind of went through with the help of the folks at Thunderstruck Motors. They helped me kind of select a motor that I thought was the right horsepower, the right torque, the right amperage. So this particular motor is 450 amps peak, which is just the peak, which you probably rarely, if never, hit, and around 200 RMS amperage. So, okay, so then based on that, what is the size of the controller? What is the size of the cabling? I may have mentioned this before, but Thunderstruck Motors sells a kit, which kind of takes all that into account. So the kit, the motor is pre-wired with, is it pronounced 20 or 00 gauge wire? So I'm like, okay, that's, I'll need at least, I'll need wire that's that thick or thinner. And now I know my amperage considerations. And then I settled on a 48-volt battery pack for the distance that I was looking for, which I promised the customer it would go something like, we said, like, hey, it'll go between, let's say 10 miles. Let's say, that's it. It's not a big range we're looking for, so I don't need a huge battery pack. Let's keep the range down. They're saying, look, we're just going to drive it around downtown for, half an hour and we're done. So I'm like, great. Then that's, we don't need that much battery consideration. So yeah, so based on that, your question was about the contactor. So if we know that 200 amps is the RMS and 450 is the peak, then I need a contactor that will accommodate that. In the kit that I bought, it actually had the contactor already chosen for me. So that was like one less consideration. So I wish there was a better story about like how I carefully, calculated and considered the size of the contactor. But to your question, Aaron, the contactor came with this motor kit, which was all sized, and the motor controller was pre-programmed for that motor and that. And I told them, the specs of my application, like this is the weight of the vehicle, this is the speed I want to go, this is, the acceleration, and so they took care of that programming for me. So it was a great deal, I think. Instead of buying individual components, as when we do more custom, then I'll do all the programming myself and do that myself. But for this project, it was selected for me. Great question.
About the DC to DC choice. Is it a standard DC to DC from some other application, or is it not an automotive unit?
So it's an automotive unit, and again, just kind of going to the website at Thunderstruck Motors and looking at everything they offered, and in my mind, having read the 2 books on conversion, I'm like, okay, I know I made a 4-page summary out of those 2 books, like 2 full, let's say 200 pages, about 400 pages. I reduced it down to 4 pages of notes. And I was like, okay, this is what I want for a motor. This is what I want for controller. This is what I want for contactor. This is what I want, for every last thing I could think of, I wrote down like what I wanted. And so I went to Thunderstruck Motors. I looked under their DC-DC converters. I'm like, look, everyone uses 12 volts as their standard for charging their phones. We're going to want one of those to power up, your standard kind of peripherals, lights, turn signals, etc. So that's why I went with the 48-volt pack that I have, converted down to the 12-volt that we need to run the accessories. Great question.
Are you going to have a 12-volt battery in line, or is it going to power entirely off of the DC to DC?
Well, we will have a 12-volt inline, 1 for some protection and 2 for some kind of regulation in case there's any spikes or anything like that. Just want to make sure that there's no problems there. Why not? Good question.
Could you share a little bit about maybe, I know you've talked about reaching out to a variety of people to talk with them about doing this. Can you share a little bit more about the community that you've been relying on to dig through
Sure.
this topic?
so fair enough, and hopefully Michelle can relate to this. That last event we had in town, and maybe you could help remind me where, Aaron, I met you and I met Fred, and then Michelle was there, and it was during COVID. But just being able to connect with you folks was definitely helpful. You know, whether he realizes it or not, Fred has been a great resource for me. The other person is Mark. There you go, Mark, over at Moment Motors, and I came to Mark and I said, Mark, I'm not trying to steal your business. I just want to learn about what you do. And Mark actually said, Kevin, I would love it if you would steal some business from me. We have way too much to do. We're not able to get to everything. We're having to turn customers away. There's more than enough room in Austin for more than one EV conversion shop. And I shared with him, hey, we're a little scrappy startup, kind of, running out of our garage here. And he was like, or rental, like we're renting a garage by the hour. And he's like, I started the exact same way as you did, Kevin. Don't worry about it. I, rented garage space by the hour at an auto mechanic shop. We shared the space, and that's what I'm doing now is, we're in a shared space called DIY Austin. So those folks at DIY have the additional mechanical knowledge about fixing vehicles. And then Mark has been a great resource as far as helping me source product. Mark at Moment Motors pointed me at quite a few different people and different vendors that resell this stuff, and has been a great help. And then the last one I'll mention as far as helping is that, of course, I joined the Facebook groups and online communities where people talk about this and people are doing this and have experience. And so if ever I have a question, in fact, just yesterday, I was asking like, hey, between the battery and the controller, do I really need 00 gauge? 2-0 gauge, can I go with something less? And so, everyone's got an opinion, and all the people threw in the chat, their opinion, and was able to kind of help me guide me as far as what size gauge wire should I use and contactor, etc. It's been really helpful to have a community of folks that do this from around the world. I mean, this is not just US based folks in the Facebook groups that I'm a member of. One called DIY Conversions, and I'm trying to remember the other one. Is probably just EV Conversions. Is a group I found. So again, good question.
Teresa's asking, cost-wise, which is maybe cheaper, buying a used wrecked EV and harvesting the parts from it, or buying like a Thunderstruck kit?
Great question. So different people have different opinions on this, and I'm going to start by saying, a lot of people come to me and they're like, hey, I want to convert my Honda Civic, my 1992 Honda Civic. And by and far, it will be much cheaper to go buy a 2013 Tesla than it will be to convert your Honda Civic, like by orders of magnitude cheaper, because I'm not going to use used parts. I'm going to use new parts because I want it done right. And, the time, the labor, outsourcing, the machining, outsourcing any fabrication, those people, they charge, let's say $125 an hour, and it's going to take them, 20 hours or something. So you do the math on that. So let me start there. So then you're like, okay, let's say I'm going to do all the work myself, save on the labor costs. Should I source the parts new, or should I source the parts used? If it's you and you're doing it for yourself, I would source the parts used, right? I mean, finding the parts, whether it's, like on eBay or, through the EV community, or even going out and buying a wrecked Tesla and scavenging all the parts out of it, is going to be much cheaper than the route I'm going, which is like, hey, I want to stand behind my work. I'm only going to use new parts, or guaranteed Tesla modules that I know have been tested and are guaranteed to work. And a Tesla module typically runs $1,500 per module. And then a typical Tesla has 16. So it just depends. How far do you want your vehicle to go? Do you want it to go as far as a Tesla, buy all 16? Or do you want it to, can you get by with less, like 100 miles? And then I can just buy like 4 or 5 modules and put those together. So great question. Yeah. So the short answer is, and I think for those who have seen Rich Rebuilds, like the answer is, buy a wrecked EV, whether it's a Nissan Leaf or Tesla or whatever, harvest the parts, and then do it yourself. That's the absolute cheapest way. And of course, you can resell anything that you don't use or anything that you pull out of your old vehicle. You can resell those and try to recoup some costs.
So Anna was asking or mentioning that the 12-volt battery would probably be needed in order to just even start the car to throw the initial power contactor.
So,
is that true?
So you're not wrong. The other way I was going to power it, or I can power it, is it just so happens that my controller takes in the 48 volts, and one of the pins out of the controller it's got a 12 volt out, it's got a 5 volt out, so I can tap into the motor controller to power it that way. And I think the reason that kind of makes more sense for me is that now that I'm actually thinking about it, so the 12 volt battery will always be there as an always on, and so when I flip the switch, that will be helpful. But if not, right, the switch will activate the controller, and then it's kind of a circular argument, like which one gets power first. The 48 volts should always be there, so that should always be there. But I think, Anna, it's a good point. Like, it might be safer to have that running directly off the 12 volt battery.
Did you want to show us something?
Yeah, so let's do a quick little tour. So I'll just start. I'm actually using the bookshelf as so I'll just flip it around here. I realize that my camera on the laptop is not that great, but there's the book moto in progress. And then more or less, I thought I'd just say, like, hey, here's the typical workstation. Oh, of course, my laptop turned off. There it is. So while we're seeing here on the, let's see if I can angle this just right. So this is the battery pack I have here. All of these wires here hook into the BMS, and then I'm actually using let's see if I can angle this right. There we go. I'm using a power supply for the time being to power the BMS, and then that's plugging in here to my laptop, which is again communicating through PuTTY and through the USB serial port to the BMS there. So I thought I just kind of set that up for you guys to kind of show you what's happening here. And then I laid out some the smaller parts that are easier to move, like this will be the DC-DC converter. Here's the contactor right here. And then I think all the other parts are strewn around the shop. So just, yeah. And then what's the last piece I have right here? I think I may have already shown this, but here's the adapter plate that I've got hanging out here that we're ready. I may have mentioned before, we had to ship the motor back due to a bad coupler. And so I wish I had the motor here today, but it's currently being swapped out and sent back. And as soon as I get it, I'm pretty much ready to put it on and finish everything up. So I feel like we're not far off. And I'm going to pick on Fred again. He said that when he got his manufacturing done, it only took him 3 weeks. So I'm like, great, let me plan on, I'll get everything lined up. I'll get everything programmed, get everything sorted. And then 3 weeks is what my plan.
Hey, just a quick follow-up regarding the 12 volt battery. I suppose if you do have a 12 volt battery, you have to worry about keeping it charged somehow as well, which would make things more complicated.
So yeah, running off my plan was then to run off the DC-DC converter, and that would be the charge to the 12 volt, and then from the 12 volt power the lights and the turn signal and whatnot.
Yeah, I got that part. I'm just saying that if you had opted to add a 12 volt battery, you probably need to have some intelligence in there to charge it periodically.
Okay, no, I see what you're saying, that there needs to be a way to monitor that level of the voltage, so, and not overcharge it. So yeah, probably, normal cars have a battery regulator, and I figured I could tap into that. Right now, this Book Moto, it had a 12 volt battery before, and it had a regulator built in, so I was going to tap into that piece that's already like on board.
And the DC to DC may actually have like charge algorithms built into it to avoid overcharging a standard lead acid battery. But one of your challenges will be when the car sits still for a long time. Not only will it potentially run down your traction pack, but it may slowly, depending on whether or not you choose to constantly charge the 12 volt, you may end up also potentially not charging it. It depends on what you choose to do.
Right. No, it's a great point. As far as, I think folks who drive EVs kind of know, if you let your EV sit in an airport, the traction pack gets consumed, keeping a trickle charge going on the battery and other components that are running in your EV. So yeah, similar concerns here. And great point. Thank you for bringing that up, Aaron.
So what
this
was
went
the
to plan,
charge
I
point?
think.
Oh, I'm sorry. What was the charge
No,
point
I was just
that
saying,
you're putting in it? Was that a J1772?
So while I did show a J1772, because everyone is familiar with that, I asked the customer up front, I said, look, do you want it to charge 220 or 110? What do you want? And surprisingly, they said and let me see if I can find it here. They said they can just charge it with a 110. And look, I don't make decisions, right? I just execute what I'm told to do. So they told me just make it a 110. So that's what we're doing. So that's, yeah, what we got there is what's it called? Weatherized with a cover with a nice seal on them. And, we've got a little spot machined out here where this is going to go. So the fabricator took care of all that. Like I gave them all the parts and we figured out exactly where we wanted all the parts to go. Again, I'm not a CAD specialist, so I just kind of pointed and was like, I brought the actual parts in. They were like, even though I had schematics, they said, look, that's great, but we want the actual part here. We want to touch it. We want to take our own measurements. We appreciate the schematics, but we don't trust it. So I had to bring everything in to the fabricator. We had to kind of put them in place, match them up, and then they built kind of to that. But again, if I had more expertise and I knew how to CAD myself, then I could have done that and brought those drawings in and said, hey, just build it like this. And it would have saved me a ton of money. And I don't even want to tell you guys how much I spent on the fabrication piece, but it was a lot just because I didn't know what I was doing and just kind of said, hey guys, here's what I want. Let me describe it to you verbally. Let me show you with the parts, and then you guys figure it out. And so they were happy to do that. And a fool was parted from his money. So, but yeah, we want to get it done, and the customer is definitely going to be happy. There's no doubt. We went to a lot of effort to make sure that we beefed this up for future use. And it's worth mentioning that this never ran. Like from the day they took delivery of it, even when it was a gas engine, it didn't run. So they were like, let's get this thing running. And I think they took a stab at, they gave it to a mechanic and tried to get it running. The mechanic just gave up. I don't know if it's because it's Italian or what, but the mechanic gave up. And so they said, well, let's try a different route. And that's when they reached out to me and said, hey, let's just rip everything out that's gas powered and make it electric. And I'm like, cool, I'm your guy.
That's great. Somebody was asking, and I think you mentioned maybe 10 miles-ish, but is that the estimated range?
So I'm hoping that it'll actually do a lot more, but I wanted to keep expectations, reasonable. And so that's why I only promised, as much as 10 miles of range and something like 30 miles an hour max speed. I'm pretty sure it's going to do more on both the top end speed and the range, but until I get to the testing phase, which if you remember from my life cycle chart is the last phase, then we won't know for sure.
Yeah.
But it's a reasonable guess.
Sorry, there's a recommendation to use a small solar panel to keep the 12-volt battery topped up if need be.
Nice. I wonder if the customer would permit that. I know they want it to look somewhat similar to the original form. That would be really neat though, and not a bad idea. So let me suggest it to the customer and see if they're open to that idea of putting a solar panel on the top. And that would definitely save the traction pack from getting drained. I like it. So my lithium ion phosphate batteries are nominal 3.2 volt, and I've got the high voltage condition set, just make sure I'm reading this right, set at 3.6 and a low voltage condition set at 2.8 to disconnect. So I don't know if you could scale for your application. You're saying 3.8, 4 volts, but I was just giving you an idea for mine at 3.2 what the range is for charging and discharging. And to be fair, I wanted to mention on my 48 volt pack, just to keep things completely like balanced, I actually did 16 cells where 15 would have been closer to 48. So the 16 cells together is, what is it, 51.3? Yeah. So it says 51.3 volts, which is close enough for my application to say, hey, I'm powering this motor and it's going to have a little extra range or extra boost actually to it, so it's not going to impact. So sorry, I couldn't answer your question about the, now I want to Google it while we're here. What's the name of that battery? But yeah, go ahead if there's any other questions.
Anna has one.
Hey, Kevin, have you given any thoughts to doing battery swaps for Nissan Leafs? I mean, that seems to be a popular thing that people want to do, but there's only one Nissan dealer in town and they are kind of hard to deal with.
Oh, really? That's interesting.
Yeah.
So I was going to say that there's already, and I hope they didn't go out of business, but there's already a Nissan Leaf specific repair shop that focuses on repairing, and they're on 183 and gosh, where does it come together? Like where Mopac and 183 come together, I believe. So, and if again, I'm trying to present, so I don't have their name handy, but I remember seeing them and going, because it was the pandemic, I went down to talk to them, but there was no one there that day. So I just kind of gave up and went back. But I definitely, since you reminded me, need to go back and just touch base and say, how's business? And do you want to join forces, or kind of what's the deal there? But yeah, it's certainly a consideration. I'm an equal opportunity or agnostic when it comes to EVs. I'm happy to work on any EV that comes our way. And so, yeah, so repairing, replacing, swapping modules in a Nissan. Yeah, same. Only, we of course have to have a car lift because those batteries, they come out the bottom. I guess the same is true with the Tesla. So, we've got to have access from under. And if I had my choice, I like to focus on things I can access without the lift because of the additional complication there.
Yeah. Okay. Yeah, I ask around to see if we can find that Nissan outfit that you mentioned. That'd be useful to know. Thanks.
You're welcome. Great questions.
All right, we're coming up to 5 minutes before the hour, so I want to go ahead and suggest we close up shop here. I want to thank you very much for offering to present and spending your time sharing this adventure that you've been on. And I want to remind everybody that this is one session in a series of sessions that we're doing for National Drive Electric Week. And you can find that agenda on our webpage at austinev.org. And there you'll also find an opportunity perhaps to join the National Electric Auto Association. We are their local chapter, and it's a fairly small fee, and they really appreciate the support. So thank you so much, everyone.
Well, that's all for today, folks. If you found this video helpful, please smash that like button, and more importantly, please subscribe. That's how we make more videos. Until next time, this is Austin EV Only.